talk about that a little bit more later. So here's here's a couple of parts. We've got this back piece, which has two bends, one bend here, and, which you can't see what I'm doing there. It's not a pointer. I'll make it gold Aladyne. How about that? It's a yellow. Anyway, so we have this back piece. That's folded up, and it's got round holes punched in it. And then we've got a seat, which is also folded up, and I'll explain what I mean by folded up in a moment. And then same thing with these legs. So the legs in this example, what I've done is done legs that are like this, sort of an L shape. And that's to give it that stiffness that we need in the vertical direction. You could also bend a square like this, kind of like an extrusion, to get that strength. But you will want to bend it. You don't want to have a leg that just comes down as one straight piece of sheet metal, but you'd have to use some incredibly thick sheet metal to have that support weight without bending.
How thick is that one there? This is stainless steel.
Oh yeah, so, I'm sorry, what was the question?
How thick?
So if you properly design the legs like these first two that I did, they would probably be, I think like 16 gauge. I don't know my gauges by heart, but like something around as less than a 16th of an inch thick would be strong enough to support your weight. And even some torquing and stuff that could happen if you swivel around on the chair or whatever. But if you went with, so that's, let me get this first. But don't do that. Because if you tried to do that, then you'd have to probably use something in the area of, 1/4 inch thick steel or something like that to have that leg work. And that's getting almost beyond what you could cut with a turret. It's just this steel would destroy the dies, and the shop would just tell you you're crazy, we're not doing it. Okay, so that's what these front legs look like. I actually don't know how you make the back legs and the back. Well, let me think about that one for a minute. I should have made those back legs separate. Maybe it could be made as one piece. So the back is, again, it's folded to give it stiffness. And then, see, as it comes down into the leg, it does this. And it gets folded here. Yeah, I guess that would work. Looks like it gets out on one sheet, or one piece.
As it does when welded together.
Well, so yeah, so I should change this design, because that's, I'm kind of complicating things there.
Those are just opposing poles.
I just put a thing here. So that's the back of the chair now. And then there's maybe the legs in the back come up a little bit higher, and they get riveted together. The seat is what they call a sort of a box section. So if you look at the underside of the seat, it looks like this. We fold it up. I just got turned around. We fold up all the sides. So it starts out looking like this when it comes off the turret. It looks like that. And then once you put it on the brake forming machine, which I haven't talked about yet, these dotted lines will indicate where you're going to be bending it, and you'll bend it up into a hollow box like that, and then flip it over, and that becomes the seat of your chair. So because we've moved material away from the neutral axis, right? See, there's that term. We now have a very stiff seat because we're taking advantage of that material that's, again, away from the neutral axis. If that were a flat piece of metal, once again, you might have to go with like 1/8" thick steel to actually support your weight and not have it bend at all. But if you go with this stuff, you could probably go with 048 thick material, which again, I think that's 16 gauge, I can't remember. Maybe 1/16 of an inch, I don't know exactly, but somewhere in that range. Yes?
If you added another one, can you fold it twice so that it doesn't have a hard edge on the end or a sharp edge on the end of it? Like fold the end up to it so that it doesn't, so that it's.
Oh, yeah, so there's something called a hem. So you can take the metal and then bend it over on itself like this. So, and that would be like along these edges?
Yeah.
And that's a hem, and yes, you can do that. It's difficult to have it fold over at a right angle in that area because you can't get the tooling in there to make that happen.
Yeah.
So, but a hem you can definitely do. Okay, so now that this is just an example, right? Yours doesn't have to look like this. It's riveted together. Well, I guess I should talk first about the brake forming. We're good on time. Okay. So after you turret punch your part, then you're going to brake form. And the brake form has tooling that looks like this. Like if I wanted to do a 90-degree bend, there'd be a piece of steel like this. And then another piece of steel like this. And then your sheet, you lay your sheet across here. And then you push down with a tremendous amount of force. And it folds that sheet into your 90-degree bend. So, look like that.
So bending chair number 1, right?
Yep, we're still on chair number 1. Now, it doesn't have to be a 90-degree angle. They have a variety of angles available, and there's even ways to get things that aren't on even numbers, but it's best to choose like 90, every 5 degrees, something like that, are going to be readily available. Again, you'll see this on the field trip, but just so you can get a little bit of a reference now, these things they almost look like extrusions, except that they're solid. They're big, long things like this. So you lay your whole sheet across that thing, and then bend it like that. There's still an operator operating this machine, but he doesn't have to use any strength or anything. He just presses the button and it does its thing. Actually, he presses 2 buttons to make sure that one of his hands isn't underneath the tool, because his hand would be gone. So he has to use both his hands to press 2 buttons. Actually, some of them they've actually got it to where these guys are just, I guess they're being really careful, because they've got some that operate with the foot pedal too, so that they can kind of hold the piece and manipulate it, but I wouldn't want to do that. Okay, so, oh yeah, so now you can also do these dies or tools for bending. I showed you this one, which is for a right angle. You can do a number of different angles, as I mentioned. You can also do, they can have big radiuses in the bottom, in case you want your bend to be like that. So that's another option there. Now, one thing that's really difficult to do is if you wanted to bend a piece that looks like this, it's really narrow and really deep. It's really challenging to do that, especially if, let's say you have another bend here. because it's hard to get this tool down into this cavity to make that happen. So there's limits to what you can do from that standpoint about how far you can get in there. They call it a gooseneck. There are tools that can kind of get in there and give you some of this effect, but you can't go really deep with it. So kind of want to avoid that. So like if you're looking at the side of your chair, I was just mentioning this can't be done. It can, but it's just kind of difficult to actually have a section on your chair that does that. They could use a gooseneck tool to go in and bend this. But it's challenging. And you can't go very far with this bend. Okay, so we've now punched our parts, and we've bent our parts, and now we need to assemble our parts. And for chair number one, I'd like you to use rivets. Just sticking with the ugly industrial look. Actually, it doesn't have to be ugly. Some of these can look pretty cool. A lot of students end up putting more rivets than you actually need just because they think they look cool. So, riveting is you take one piece of material like this, and then a second piece of material like that. They both have holes punched in them. And then you take your rivet, which sort of looks like a little mushroom cap screw or something kind of like that. And it's hollow through this region. And you put your rivet in there. And then the riveting machine, it's kind of like a drill press. You pull a handle down or press a button depending on which kind of machine you have. It squeezes the rivet and squishes it so that it gets a mushroom on the other side as well, a mushroom cap on the other side. So this gets squeezed against this like this, and then the rivet deforms. And now those two pieces of material are connected together, and you can't take them apart unless you drill out that rivet. So this is not a good technique if you plan on taking something apart. But if you don't plan on taking something apart and you don't care about the aesthetics too much, it's a great technique. It's super fast, cheap, durable. Excellent way to join two pieces of material together, two pieces of sheet metal together. So that's how you're going to join your pieces. So maybe we have a chair leg that looks like this. And then you have a chair seat. It looks like that. And then we would maybe rivet it together. A couple rivets there and there. Something like that. That would be a technique for it. Now you can even get even additional strength out of this, right? Because now that L shape is opposing the other L shape, and you get some really nice structural features going in there. Let's see, go back to the two chairs again. So I want you to have turret punch holes. So I'd like you to have some holes on your chair. They can be whatever shape you like, as long as they're sort of standard sort of shapes that the sheet metal shop would have. Whatever that means. You can decide what you want those shapes to be. Now I don't know if they would gold Aladyne these afterwards or before riveting together. I'm not sure, but anyway, gold Aladyne is kind of the final step. That's your finishing process. So, wanted to talk a little bit more about bending. I'll do it on this page here. So, I talked about the seat of the chair looked something like this before it's bent. What's commonly done is to put what's called a bend relief in these corners. Sometimes like a little round punch like this. Other times, let's say we're trying to do a sheet like this, and we want to bend. We just want to bend this one little leg here so it would look like that. We want to bend it along there. This one here, we want to bend along here. So it's bend relief. What it does is it allows the material to bend without distorting at the corner. And the same thing would happen here. Imagine if you had a sheet of metal and you tried to put this kind of bend on it. It's going to get all distorted in this area where you're trying to bend. So what we do is we put a bend relief in it. It's like this little notch. This eraser's not going to work, right? Yeah, it just disappeared. Okay. So you put a little notch in there. And that notch is typically about equal to the material thickness in both dimensions. So if we're using